Okay, welcome to today's lesson, which is area of triangles and quadrilaterals. Now, it's probably worth mentioning what a quadrilateral is straight away. Now, the word quad comes from four sides. So, a quadrilateral is a four-sided shape. And this includes rectangles, squares, it includes trapeziums, parallelograms, rhombus. All of these come under the quadrilateral category. And also, we're looking at the area of a triangle as well, which is a three-sided shape. So, let's have a go at our first questions. So, first of all, it's probably worth noting what the area of a rectangle is. So here we have a rectangle. Let's draw this. Now, I think this one's quite straightforward. So this is the length and this is the width. And the area of this is equal to the length times by the width. Okay, so that's the area of a rectangle. Let's pop that on there just so you can see it. The area of that is equal to length times width. Now, the perimeter, in this case, is the distance all the way around the outside. Okay, the perimeter is this distance all the way around the outside, so it's going to be this length here, this width here. So the perimeter of these shapes is equal to this length plus the length, so length plus width plus length plus width. Perfect. So if we are looking at this first question here, which is work out the area and perimeter for each of the rectangles below. So the first thing we've got to do with this one here is count the amount of sides. So 1, 2, 3, 4, 5, 6 across by 1, 2, 3, 4. So 6 by 4. So there's two ways you can think about this. Now, because it's broken up into squares, we know that the area is the amount of space inside of this. So you could, if you wanted to, count the squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 24. Okay, so that is one way of doing this. However, the other way of doing it, if you do not have squares, is to think about the length times by the width. So in this case, it's going to be 6 centimetres, it's going to be 4 centimetres. So the area of this is equal to 6 times by 4, which again is equal to the 24 centimetres squared. If you want to work out the perimeter, then we need to count around the outside. So it's going to be 6, 6. Do not forget these extra sides here. Okay, a lot of people just see those two and go 6 plus 4, so the perimeter is equal to 10. Actually, we need to count all of these. So the perimeter of each of these is equal to 6 plus 4 plus 6. So 6 plus 4 plus 6 plus 4, which in this case is equal to 20 centimetres. Notice that this is equal to centimetres, not centimetres squared, because it's the distance around that outside there. And the area is centimetres squared because it's the distance, the amount of space which is inside of that. Okay, we've got another one here. So let's have a look at this one. Now this one here is 10 by 7. So 10 centimetres by 7 centimetres. Now with this one you don't have these squares inside, so we've just literally got to use the formula above, which is length times width for the area, perimeter is that distance around the outside. So the area in this one is equal to 10 times by 7, which is equal to 70 centimetres squared. And the perimeter is equal to all of these side windows. We need to put these extra sides on here. We can't forget those, okay? So it's going to be 10 plus 7 plus 10 plus 7. So 10 plus 7 plus 10 plus 7. Well, 10 plus 7 is equal to 17. Plus 10 is equal to 27. Plus another 7 is equal to the 34 centimetres all the way around there, like so. So, if you are have a little go at these questions, so I'll put these up. If you're finding these really easy, you might want to skip this part. But there's some questions for you to have a go at, so make sure you copy these in your book, make sure you're doing these in your book. Also, I'll go back to this for a second, keep forgetting this, make sure you are getting these examples down in your book, okay? The only way to learn maths is to do it, so make sure you are always getting these examples down and copying them down in your book. And once you've done that, have a go at these questions here. So pause now if you want to have a go at them. And I'm going to unpause and put the answers on. So mark those in green. If you got all those right, well done. And we're going to go on to our next slide, which is the area of a parallelogram and a triangle. So we've already had a look at the area of a rectangle, which is length times width. Now what we're looking at is the area of a parallelogram. So the area of a parallelogram is equal to your base, which is this part here, times by your perpendicular height. Now I use the word perpendicular height because it has to be at 90 degrees, okay? This is the vertical height. So it's the vertical height. These have to be at 90 degrees. Now, what you tend to say is if you know one and you know the other one, you ignore these slanted sides. They have to be perpendicular, okay? So this one here, so the area of a parallelogram, notice I'm checking that my spelling is right, is equal to the base times by the vertical height. Base times by the vertical height. So, now we need to think about a triangle. So with a triangle, again, so we ignore the slanted sides, with a triangle, again, it's going to be the base, which is this one here. It has to be a right angle there. So again, it's the vertical height. This could be inside or it could be outside. The vertical height there, the vertical height there. Now, you'll notice this is, in fact, there's a little diagram here. So with this one here, what we're doing is it's like cutting the parallelogram in half. So when I take this out, if you look at this, I'm going to smooth this over like so. So the formula for a triangle is very similar to the formula of a parallelogram, but the difference is, the key difference is, I'll just show you that there. The key difference, you'll notice, is that it's half of this. And people always forget to do that. People always forget to divide a triangle by 2. They see the base, they see the height, they times them together, but you've got to divide by 2. So the next one to get down is the area of a triangle. Area of a triangle, which is equal to base times by the vertical height, not forgetting to divide it all by 2, okay? The area of a triangle is the base times by the vertical height divided by 2. Get that one down as well, okay? With this, it's important to say now that you do ignore these slanted sides. So see this one here, this side here, you're going to ignore this. This side here, you're going to ignore this. This length here, you're going to ignore. This length going to be here, you're going to ignore. You're only using the ones which are perpendicular. So the base and the vertical height. Okay? So that's the base and the vertical height. Make sure you've got these down in your notes. Okay? So, let's have a go at some of these then. I'm going to keep these actually, so we can always refer back to them. So, for this first one here, we've got a parallelogram. Like so. The base is 11 centimetres. The vertical height is equal to 5 centimetres. And this slanted edge here, which they've given as extra, is equal to 7 centimetres. That means that line-up's coming. So, what we need to think about here is the fact that it's going to be the base times by the perpendicular height, or this vertical height, which is 5. So the one that we don't need is this slanted side, which is 7. Okay? So the area of this is equal to the base times by the vertical height, which is only 11 times by 5. You don't just times all these numbers together. It has to be the base. It has to be the height, which in this case is equal to 55 centimetres squared. The next thing is this triangle. So here we have our base, which is 12 metres. We have our vertical height, which is 3 metres. We have this slanted side, which is 5 metres. And we have this slanted side, which is equal to the 4 metres. But the only ones that I need to know, which are the ones which are perpendicular, okay? So it's going to be this one here. So I don't need this 5. I don't need this 4. And the thing that everybody always forgets, and I'm going to keep hammering it, is that you need to make sure that you're dividing this by 2. So it's going to be the area of a triangle is equal to the base times by the height, so 12 times by 3 divided by 2. Do not forget to divide that by 2. I know I'll say it, and I know that you'll have a go at these questions, and I know that people will forget, so just make sure that you don't. So 12 times 3 is equal to 36. Divided by 2 is equal to 18. Let's just check that again. 12 times by 3, 36, divided by 2 is equal to 18. Remember your units on that, which are centimetres squared. So this is example now, I think it's example 3 and example 4. Make sure you're getting these down in your notes. The only way to learn maths is to do it. So, there's your answers to both of those. So I'm going to put some questions up now for you to have a little go at. So have a go at those questions. Pause now so you can have a little go at them. I'm going to give you 2 seconds and then I'm going to unpause it. I'm going to expect you to unpause it. Okay, I'm going to put these answers on. So there's your answers. Okay, I've popped this one on just as a little example of something that we can push a little bit further. If you want to, pause this right now, and then you can have a go at it yourself. And if you want to check the answer for this one, unpause now, and I'll go quickly through it. So I'm just going to do this one very quickly on the screen. So what we need to do with this one is we need to cut it in half. Now, notice that over here, this length here is 5, and this full length here is 12. So once we've cut it in half, we've got 2 shapes. We've got a parallelogram, which is at the bottom, and we've got a triangle, which is at the top. So to work out the area of this parallelogram, it's going to be base times by the vertical height, which in this case is 9 times by 5. And in our for our triangle, it's going to be the base, which is the same as this, which is 9, times by the vertical height, which is 12, take away 5, which is 7. So in this one here, 9 times by 5, which is equal to 45. and the area of the triangle. What are we not forgetting? We're not forgetting to divide by 2. So this one here is going to be equal to 9, which is this base here, times by the vertical height, which is 7, divided by 2, which is equal to 31.5. So if we want the total area of this, we're going to add both of these together, which is equal to 76.5 centimetres squared. Okay, so we've had a look at rectangles, we've had a look at triangles. The next thing we're going to add to our list is a trapezium. So we've got our parallelograms, base times vertical height. We've got our triangles, which is base times vertical height divided by 2. We've got our squares, let's get that one back as well. Sorry, our rectangles, which in this case was area is equal to length times width. There's 3 formulas there that we've got to remember, and you do have to remember them. So the next thing we're going to be looking at is our trapezium. So, in a trapezium, what we have is we have 2 parallel sides. We have a pair of parallel sides, and then we have 2 which aren't parallel. Now, the best way to think about this, I think, is that we're averaging out these 2 sides. So it's going to be A and B, and again, it's that perpendicular height, which is this one here. Okay, this here is perpendicular. And to work out the area of this one's a little bit harder. You've got to average out the top and bottom and then times by the vertical height. So the area of this the area of a trapezium is equal to, make sure this is nice and neat, area of a trapezium is equal to, now the way we do this is we add the A plus B, so A plus B divided by 2, A plus B divided by 2 times by that vertical height H. So the way you might want to think about this is that you're averaging out this top and bottom. So you might want to think about if you've done the mean, hey diddle diddle, the median's in the middle, you add and divide for the mean. So we're adding the top and bottom and dividing by 2 to average those out. And then we're timesing by the vertical height, very similar to the triangle or the parallelogram. And that's the area of a trapezium. Now, if I look at those, they're the key ones that you need to make sure are down in your notes. Make sure that you are getting these down. It's so important that. So, we've got this one in our notes. We've got a triangle in our notes. Don't forget to divide by 2. We've got a parallelogram in our notes. We're averaging out this one here. So let's have a go at a trapezium question, because these are pretty much all the ones you need to know now. So, we've got a trapezium question here. I'll just make it big for you so you can see it, and I'll go through it in a second. So here we've got our trapezium. And the top is 5 centimetres. I'm drawing this out, so I think this is example 5, is it? So make sure this is in your book. Example 5. So the top is 5 centimetres. The bottom is 8 centimetres. And the vertical height in this case is equal to 4 centimetres. With this one, it's probably worth writing down what the formula is. So area of a trapezium is equal to A plus B divided by 2 times by H. Now you might notice on here that in the notes they say it's a half of A times B. That's exactly the same thing. A half times by something is the same as those things divided by 2. It's exactly the same thing, so don't worry too much about that. If anything, I think this way is a little bit easier to think about instead of that half. So, going back to this one, we have A is our top part, B is this part here, and H is this part here. So it's going to be equal to 5 plus 8, so A plus B, divided by 2, times by the vertical height, which in this case is equal to 4. So let's do this. 5 plus 8 is equal to 13, divided by 2 times by 4. So 13 divided by 2, you can do this on your calculator now. You could do all this on your calculator, to be honest. So 13 divided by 2 times by 4 is equal to 26 centimetres squared. So that's example 5 in your book. So A plus B divided by 2 times by H. Okay, let's move on now to a different type of question. So with these questions here, you notice it's a weird L shape. So we're going to be looking at just 3 more questions, and then we'll give you a chance to have a go at some. But these here, we've got this weird L shape. Now the L shape, all we're looking at here with this L shape is we're going to be splitting it up into 2 rectangles. That's literally it. That's how we do it. So we're splitting this up into 2 rectangles. So let's draw this first one down. I'll just make it big in case you can't see it. So we've got this L shape. Make sure you're getting this down in your book, remember. If you need to pause, then pause. So we've got our L shape. The top here is 7 centimetres. This side here is 2 centimetres. This one here is 4 centimetres. And this bottom one is 4 centimetres. Now what we're doing with that is we are going to cut this, as I said, into 2 rectangles. Now I could cut up here if I wanted to, but the reason I've cut across here is because I've got the length and width of this one, and I've also got the length and width of this one here. So I've now got 2 rectangles, A and B. So if I'm working out the area of A, it's equal to, so the area of A is equal to my length times by my width. So it's going to be 7 times by 2, which is equal to 14 centimetres squared. The area of B is equal to 4 times 4, which is equal to 4 times 4, which is equal to 16 centimetres squared. And then we've got, because we've got 2 areas, and they're both separate areas, we're going to add these together. So it's going to be 14 plus 16, which is equal to 14 plus 16, which is equal to 30 centimetres squared. Now, take note with this one, I've got to split it up into these 2 rectangles. A lot of people, when they see this, they just see some sides, multiply them all together for area. That is not what we do. We've got to split it up into 2 rectangles, find the area of this top one, and then find the area of the bottom, and then we can add A and B together to get the total area. Okay, let's have a look at this next one now. So this one here, it seems like it's very similar, but actually there is a little bit of a difference in this one. And this is where it starts to get a little bit trickier. Not too much harder, but there is something that we need to spot and think about. So, here we've got our lengths. Remember to get this one down. This is example, I think it's 6 now. So again, we're going to split this up into 2 rectangles. But we have to be really careful with this. Okay, so I'm going to split it up into 2 triangles. I'm going to split it up into this this rectangle here, which I'm going to call A, and this rectangle here, which I'm going to call B. And what we need is the dimensions on both of those. So the dimensions on the first one here, quite straightforward because it's the height is 8, the width is 3. Okay, so on A, this bit here is 3 and this bit here is 8. However, on B, we can see that the height is 2, but we only want this distance up to the dotted line. We only want that distance there. And this distance here, for the rectangle, the base, if I'm cutting this off, that distance there is not 8. Okay, that distance there is, so this full distance here is 8, and this little distance here is 3. So this full distance here is 8, this little distance here is 3. So to work out this distance here, which is the length of this, it's going to be 3 plus something makes 8. So that something must be equal to 5 meters. Because I know that this is 3 and this is 5, which makes the total distance here of 8. So now when I'm doing this, I've got both lengths now. So the area of A is equal to 8 times by 3. So 8 times by 3, which is equal to 24 centimeters squared. And for B, it's going to be equal to 5 times by 2. So the base times by the height. So 5 times by 2, which is equal to 10 centimeters squared. So a common mistake there, I think you can probably spot it, is that people go 8 times by 2, 8 times by 3. But it's not 8 across here, it's only 5 across here. So 5 times by 2. Then we're going to add these together. So it's going to be 24 plus 10 is equal to 30, is equal to 34 centimeters squared. Like so. So, that's those 2 questions done. So, we've got one more question to go through, and it's going to be this one here. I'm going to pop this one up for you. Now, this one here is another compound shape. But what we're looking for here is we're looking for the purple shaded area. So what we've got to think about here, and get this one down, this is going to be example 7 in your book. So with this one here, what we've got is we've got 2 shapes that we need to think about. And what's happened here is you've got a parallelogram, you've got a triangle, and the triangle has been taken away from the parallelogram, so it's been cut out of it. So to get rid of that, what you need to do is you need to take away that area. So I'm going to think about this in 2 parts. The area of the parallelogram, and then the area of that triangle. So here, we know the base is equal to 12 centimeters. We know this vertical height is equal to 9 centimeters. We know this part here is equal to 11 centimeters. And then inside, we've got our base, which is 8 centimeters. We've got our vertical height, which is 5 centimeters, and this length here, which is equal to 9.4 centimeters. Now I'm just going to bring the sheet back that I had before, because this, again, this is the one that you need to refer to all of the time. So this sheet here, you need to know all of these areas. Parallelogram is base times vertical height, ignoring that vertical side, sorry, the slanted side here. They must be perpendicular. This one here is your base times by your vertical height. It could be inside, it could be outside. Again, ignoring these 2 slanted sides, they must be perpendicular. Here we've got A plus B divided by 2 times by H, and again, that must be perpendicular. So with this one here, if I'm looking at the parallelogram, I'll do that first. So the parallelogram, let's make sure I spell that right. The parallelogram is going to be the base, which is 12, times by the vertical height, which in this case is 9, ignoring that slanted side, which is 11. So 12 times by 9, which is equal to 108 centimetres squared. For the triangle, it's equal to base times by vertical height, not forgetting with a triangle to divide by 2. Don't forget that. So 8 times by 5 divided by 2, ignoring in this case the 9.4, because it's only the perpendicular height that we want. So 8 times 5 divided by 2 is equal to 20 centimetres squared. Now you might be tempted to add these together, but that's not the case in this one. What's happened is the triangle has been taken away from that parallelogram. So it's this part here, the full area of the parallelogram, take away the area of this triangle. So it's going to be 108, so the area of the parallelogram, take away the area of the triangle, which is 20, to get this shaded part here. Okay, to get that purple part. So 108 take away 20 is equal to 88 centimetres squared. So that's all of the questions, that's all the examples, that's the last example that we're going to do today. I'm going to put some questions on, have a go at these in your book. So let's transition to these. You'll notice that it's some of the L shape, some of the T shape, some are trapeziums, and some are the compound shapes we've just been looking at. So have a go at these questions here. So pause now so you can have a go at them. And I'm going to pop the answers on. So there are your answers. And thank you for watching this lesson. Make sure that your work is always copied into your book, and have a nice day.